Hello again, Algebra 2 class. Before we start the new material for this lesson, we have to backtrack a little bit to a skill that's going to be very important during this entire unit. That skill is factoring, which you might remember from earlier this school year when we were doing our units on quadratics and then on polynomials. So we'll start off with a simple definition. The factors of an expression are quantities that when you multiply them together result in the original expression again. Or another way of thinking about it, the factors of an expression are things that divide evenly into that expression. So we have a few examples here, starting with very simple, like 4 times 5 equals 20, which means that 4 and 5 are both factors of 20. And moving up to more what we'll be working with, which is seen in examples B and C, where you're either multiplying two linear terms together, like in example C, to get a quadratic, or where you are multiplying a monomial, like 2x squared, times a linear term to give you a higher order polynomial. In both cases, again, the factors are the smaller pieces that when you multiply them together, give you whatever it is that you had as the original big expression. So we'll start with factoring out the greatest common factor, commonly referred to as the GCF. Essentially, the idea here is that if we have a polynomial, we can divide out the biggest thing that is shared, the biggest factor that is shared by all of the terms in the polynomial. So in example A here, we can see right off the bat that all of these have x, which can divide evenly into them. So I know that I can factor out at least an x. We can also see that 3 goes into 3, 12, and negative 6. So we can factor out not just an x, but actually a 3x. Well, when we divide that 3x out, if we divide 3x out of 3x cubed, we're just left with 1x squared. If we divide 3x out of 12x squared, we're left with 12 divided by 3 is 4, x squared divided by x is x. And if we factor 3x out of negative 6x, we're left with just negative 2, and no x is left. And that's all we have to do on that one. In example B, similar problem. Start the numbers this time. We can see that if I'm looking at 14 and 21, the biggest number that divides evenly into both of those is 7. And the highest power of x that divides evenly into x to the 5th and x to the 3rd is x to the 3rd. Pretty much you just grab the lowest power on your variable. Now, when I divide that out, that leaves me behind with 2x squared. And when you divide it out of the other term, leaves us behind with 3, and no x is left behind because we factored all of them out. Other kind of factoring that's going to come up is factoring quadratics into linear factors. Now, first we'll go the other direction. You might recall from maybe Algebra 1 this mnemonic device called FOIL that you can use to multiply linear factors. Well, that just, remember, stands for first, outer, inner, last, and it is a way to kind of make sure you do all the different pieces of distributing. So in this case, if we do x times x, we get x squared. If we do outer, x times negative 2, we get negative 2x. If we get do 5 times x inner, we get 5x. And if we do last, 5 times negative 2, we get minus 10. That, of course, then simplifies down to be x squared plus 3x minus 10 after we combine like terms. And one thing you can see here, which will help us with factoring, is that x squared, that first term there, only came from the first part. So this came from first. The 3x came from outer plus inner. And then the negative 10 just came from last. So when you're going through and you're factoring just goes the other direction. So it is actually possible by looking at the first and last term in your quadratic to kind of mix and match what could work for those to find what actually does work for the whole thing. Now, what does that actually mean? Well, if we break this down, we're going to factor this quadratic into two linear factors. We'll start off with our parentheses here. We can look at each piece. The only way to get x squared at the beginning is if my first distribution is x times x. It's the only way to get x squared. There are multiple ways to get 12, right? There's 1 in 12, there's 2 times 6, there's 3 times 4. But only one of those, specifically 2 times 6, adds up to 8. So we know this has to be x plus 2 times x plus 6. And you can always check again by distributing just the outer and inner. So we get 6x plus 2x. In example B over here, things are slightly more complicated because we don't have a 1 out front anymore, but there's still only one way to get 2x squared, 2x times x. And there's also only one way to get 3. In this case, because we know we have to add up to a negative number in the middle, and we have to multiply to 3, this has to break down to not just 1 and 3, but actually -1 and -3. The only thing left to figure out is where does -1 and -3 go? If we put -1 here and -3 here, let's try that first, then we're going to get 2x squared, that's fine, minus 1x, minus 6x. So that gives us minus 7x in the middle, which means that didn't work. However, if we choose something a little bit different, we could do minus 3 and minus 1 instead, because this still gives us that plus 3 at the end for our last part of the distribution, but now in the middle we get 2x squared, we get minus 3x and minus 2x, which gives us that minus 5x. So this actually does work for our factoring. I know this is running a little bit long right now, but this skill is going to determine whether you can do most of the problems in this unit. So I just want to run through one last example. Remember, if you don't like mixing and matching, or if the numbers are getting big, or there's too many options to choose from, master product, which we looked at earlier this year, is another way to factor. This requires, first of all, doing a times c, the first coefficient times the last, which in this case would give us -12, and then finding the factors of -12 that add to b. Well, we've got 1 and 12. Doesn't seem like it's going to work. We've got 2 and 6. We've got 3 and 4. Well, you might be looking at this and realizing if we pick, in this case specifically, -2 and +6, that multiplies to -12 and it adds to +4, which tells us then how to break up this term, this expression over here. Because we can now split that 4x up into -2x and +6x. Which from here we just factor by grouping at this point, so we can take a 2x at the beginning, leaving us behind with 2x minus 1. And we can take a 3 out of the second part, a +3, which leaves us behind with 2x minus 1 as well. Remember, your parentheses always have to match here. We can now factor out the 2x minus 1, leaving us 2x plus 3 as the other factor. And now we are done factoring this.